Hey, so this is 6.3. We're going to be using the normal distribution, which in other words just means word problems. Yay! And in the last section, I gave you two options. I said you could watch the first video, which is the new calculator, or you could do it with the old video using a table and using a different calculator. That probably wasn't the best idea I've ever had because really this new calculator is where it's at. So I'm going to do this first problem the old way with the table for anyone that watched that video, for anyone that really loves their calculator. And then, so when you see that part come up, you can feel free to fast forward to the calculator part. But then I'm going to do all the rest of the calculator because you're going to see how dreadful that table is. Okay, so let's just get started. We have the first problem. Okay. So we have the first problem here, and it says the random variable x represents a randomly selected 3-year-old's height, where the distribution for the score is normal with a mean of 38 and a standard deviation of 2.5, both in inches. So there's our mean, there's our standard deviation, and we're looking for between those two ages. Okay, fabulous. So if we were to do this the long way, I don't know why my pen's so fat, but that's good. We have our normal distribution. I'm just going to draw my bell curve here. Maybe, okay, here, ignore that dot. Ooh. Okay, pretend that's a bell. And we have the mean in the middle. And then we're going to have, so the mean is 38. I'll type that in a minute. So 41's over here, 44's over here, and we're looking at, get off that line, this in between this right here. It can't hurt for everyone to just see what this picture looks like, if nothing else. But when I get to the table part, it might get boring. All right, so this middle is 38. This lower bound is 41. And this upper bound is 44, because we're looking for everything between 41 and 44 inches. Okay, so we're going to use these x's, the 41 and 44, and we are going to do the upper and lower bound, find the areas, and subtract to get those two right there. So let me just show you. I'm going to tell you something. I am going kind of fast through this because I hate it, and I think you're going to absolutely love the calculator. I just want to show you how dreadful this is, and then we'll do the calculator. All right, so we're going to use our formula for z-score, and that is that z equals x minus mu. So the upper bound is 44 minus 38, all divided by the standard deviation. Voila. Draw a line for my fraction bar. Okay, and while we're typing, we'll do our lower, and then I'll put it on my calculator. Our lower bound, or our lower z, is going to be 41 minus our mu all over our standard deviation. So we have our two x's here, our upper bound and the lower bound of this. Oops, I thought I was going to make a straight line of this picture. And this kind of looks like that last worksheet we were doing, where we wanted this in-between part to figure out. So we have to calculate the z-score like we did in 6.1, apply the z-score like we did in 6.2, and then we will get our answer. So the upper is going to be 44. Let me just type that into my calculator. So I'm calculating, oops, I am still over here. Let me, okay, yep, there it is. I am going to get my fraction, and I want, oops, I don't want the answer. I want 44 minus 38 over 2.5. So this will be the first answer. And the second one, I can just copy this. Ooh, too much information. Copy this, so I just highlight it by using these up and over keys and whatnot. And then you hit enter and it copies it. And I'm just going to change my 44 to a 41. Okay, so I have my upper and my lower. let me go back to typing. So the upper z-score is 2.4 and the lower z-score is 1.2. Okay, interesting, good to know. Now, at this point, if you didn't watch the second video, this is where you kind of want to skip ahead of like maybe 30 or 45 seconds. But what we did in that second video is we took that z-score and we changed it into the probability or the area using our table. So let me stop this, go up to my normal distribution. Is this going to be messy? Okay, well, we will hopefully you have this if you care about this. We have 2.40 is 99.18. I'm going to write that down so I could type it in a minute. And 1.20 is 88.49. Going back here, getting my text back. So this is going to tell me that the area for the upper was 99.18. And this tells me that the area for the lower is 88.49. And last but not least, because I want in between, we are going to subtract. And we are subtracting the upper minus the lower. And if you do it backwards, you'll get a negative. So the area is always positive. So make sure we get a positive. I'm going to come over here, type that into my calculator, 0.9918. Oops. Let me try that again. 0.9918 minus 0.8849. And I get my final answer. Let me type it in, please. It's going to lose my annotation right there at the very end. Okay, well, I'll just type it right here. It could be a different color. That's okay. Oh, gosh. What happened? Did I change my colors or change my answer? Okay. So sorry. I need to go back and find that answer because I already forgot what it was. Right. 99.18 minus 88.49, 10.69. Write it right over here. That right there, my friends, is the probability that a randomly chosen 3-year-old is between 41 and 44 inches. Okay, the picture is a good idea. It's a good idea to know what exactly we're calculating. But that was a lot of calculations just to get one teeny tiny answer when this magical calculator can do everything that we need. Okay, so this is what we're gonna do. We did this the other day. We just by the other day, I mean the other video, but we had the same mean and sigma every time. So this time we're gonna change. Okay, so as a reminder here, let me go home. We start at calculations. We're gonna go down to distribution. We are doing normal distribution. So we go down to the fourth one and click OK. And it asks us for mu and sigma. Again, in the last video, every time mu and sigma was 0 and 1. But now you can see that mu was 38. The mean was 38. Let me try one. Here's my mu. And then my sigma was 2.5. So I come over here. I type my mu is 38, execute. My sigma is 2.5, execute, and then go to next. And now this picture does not look like this picture, so I want to make it look like that picture. So first I'm going to hit over and go down to in between, okay? And then in between what? I want this in between 41 and 44. I hit over. Let me do that again. I hit over, 41. Over 44, enter, and it's the same answer. Woo! Okay, so obviously I like this one better, right? Same answer down to the nearest to 4 decimals because we would round that 7 to a 9. And so this is going to be where it's at. So I'm going to still draw a picture but I'm just not going to do all of these calculations when I can just skip to the answer in my calculator. I like to draw a picture because then I can see if it matches the picture. Okay, so let's go, okay, let's go to number 2. I really like these annotations better than what I've been using. So I'm just going to use them more. Here we go. Here is my curve, bell curve, as belly as you can. Oops, that's not how you do it. As bell, oh, okay, well, it's skinny again. Who cares? And we want, in this problem, well, we have a mean. I guess I should talk about that first. So we have a mean of 134, a standard deviation of 34, and we're looking for the probability that a baby elephant will weigh more than 250 pounds. Okay, so right in the middle is the mean of 234. Which side is 250 on? So we put a line here at 250. So I will write those in. So this middle is always the mean. And this cutoff over here is 250. And we're talking about more than 250. So I am going to shade, I'm just going to use that one here. So I'm going to shade all of this more than stuff. Okay, looks like a 3-year-old colored it, but hey, I'm shading with my right hand, so what can you do? Okay, you get the point. We want the picture to look like this with our mean and our standard deviation. So I will go over here to my calculator. I need to go back. I don't need to go all the way back. I'm already in normal distribution, but if I stay where I was, you could see it's kind of tiny. See that mu and that sigma are incorrect. So we are going to just, I can't get it over here. Wow, my computer's mad at me. Okay. The end. So I'm going to go back. I'm going to do mu is 234, enter. The sigma is 34, and this picture in this corner, I guess I want to make it big again. I think I can make it big over here. Full screen. Ooh, that made it worse. Okay. This picture in this corner does not look like my picture here, so I need to go over and down to the bottom. So now this picture looks like this picture. This picture, I haven't changed anything yet, but this picture and that picture look the same. Okay, so make things tiny again. Okay, so the reason this is all shaded right now is because I haven't changed my P, and it says P is greater than 0. Well, where's 0? 0 is like way over here. So anything greater than 0, that's everything's going to get colored in. I don't want 0. I want 250 because that's where my cutoff is. I type in 250 and I get point, let me write that down over here. The probability 0.3190. We're always gonna, well, I guess we'll go to whatever the assignment says, but we'll just do the 4 decimals on this assignment here because that's what the table is. So again, that 89 raises to 90 because of that 6. All right, not too shabby. Let's draw one more picture. Maybe. Oh, I don't like these lines. I don't know why my annotate won't just. Oh, here we go. I'm hoping you're drawing the picture while I'm just making noise over here. Draw the picture. Bell curve as best you can. Okay, this time, what are we doing? We are doing a mean of 450, a standard deviation of 150, and more than 700. Oh, good Lord. Someone's texting a lot. Okay, so right in the middle, we have 450. That means 700 is like way over here. Does not need to be drawn to scale, but ish-ish is good. And I want more than, so I have this little guy shaded over here. As a reminder, the numbers in the middle. I'm kind of running off the screen, so I'm just going to write them above right now, above my number line, or like kind of like on the number line. That's 450, and then this one is 700. That's how we know what side it's on, because mu is always in the middle, and then we decide what side x is on. Okay, so I go back. I go back. I say the mean is 450. The standard deviation is 150. Next. And again, it always defaults to less than. So since I want more than, I'm going to go to the bottom. And I have more than 700 text. Yikes. Not very many. Look at that. A very small percentage, 4%. So we would say something like the probability. Why did that happen? I didn't. Literally, what is that? Oh gosh, did it change pages? Okay, whatever. I'm just going to type right here and just pretend that didn't happen. Probability is 0.047. One more will be 8, because a 9 tells a 7 to turn into an 8. All right, what do you think? Not too shabby. I think I like the calculator a lot better than all of this algebra up here. Ooh, okay, good. I'm glad you guys agree with me. Okay, so let's clear all of this. And whatever I typed in PDF, that's fine. It'll just. And we're going to go down. We have a few more. Okay. This one is kind of like the first one. And it says the time to assemble a assemble a power iPhone at a certain plant has a normal distribution with a mean of 5 hours and a standard deviation of 3 hours. What is the probability that it can be assembled between 3 and 8? And this time it tells us to round to 3 decimals. Okay. I'm going to draw a picture, kind of sort of picture. Bell curve. Now, the mean is 5. That's in the middle. 3 is on this side of 5, and 8 is on this side of 5. So let's get those lines in. And, well, it doesn't need to be that high, but that's okay. And so we have the smaller number is 3, the mean is 5, and the bigger number is 8. And it says we are looking for between. So between all of the space in between. And you always want to draw pictures so you make sure you're doing the right thing on the calculator. Okay, beautiful. So we go over to the calculator. Go back to mu is 3. No, it's not. Mu is 5. Mu is 5. Standard deviation is 3 hours from up here. And we want to go in between, which is the middle one. Now it kind of looks like our picture. We just got to change the numbers to 3 and 8 because we want it in between 3 and 8 hours. And there's our picture. Beautiful. It looks just like what we typed over here. So we'll say something like the probability is, and this one said 3 decimal places. I'm going to go 0.589. Okay, 5 is a little different. So I'm going to erase. So if you need those, pause it and draw. I'm going to erase so I can go to number 5. Oops, that was not the erase button. Number 5 is talking about elephants, okay? And the elephants say, or it says that the mean is 34. And the standard deviation, the mean is 234. And the standard deviation is 34 pounds. Okay, that's great. African baby elephant, normally distributed. We have our mean, we have our standard deviation. Part A says find the maximum weight of a baby elephant that is in the lower 95 percentile. So I'm going to draw that picture first. So this will be for part A. And got to get my bell curve going. And I want it to be the lower 95. So what that says to me is I want 95% of this picture colored in, the lower side. So that sounds like almost everything. Maybe not this little bit at the top. Save 5% at the top, but color in almost everything over here. Color all of this in. We know this right here is, oh wait, what do we know? We know this right here is, oh no, we don't know. That's what we're trying to find out. But we know the mean. That's what we know the mean. You got it, get out of here. We know the mean is right there in the middle, and that is 234. And then the other thing is we know the area. The area is this lower 95%. So area and probability are the same thing with this graph right here. And so if the area is, or if we're trying to find, what are we trying to find? We're trying to find the area for our calculator. We know the probability is 95%, which is 0.95. So if you're doing this on a table, first of all, why are you doing this on a table? But if you are, you want to fill in the extra zeros. But if you're doing it on the calculator, you don't need the extra zeros. So what we're going to do on our calculator, let me type in what we know. So I know, I go back. I know the mean is 234. I know the standard deviation is 34. I don't know this. I know my picture is less than. Perfect. I got the less than picture already. I don't know this number, but I do know what it equals. I want it to equal 0.95. So I hit enter, and I see that the answer for this question mark for part A is 200, what does it say? Round to the nearest whole number, 290 pounds. 290 pounds, because it says to round this X to the nearest whole number. So I put the 95%, the area, the probability on the right side, because the area and probability is on the right side. The X is on the left side. Okay. So now this, I'm not going to draw a picture because it's going to be very similar, but find the maximum weight maybe in the lower 10%. Okay. So I come back here to my calculator. Instead of 95%, I put 10%. And now to the nearest whole number, I have 190 pounds. Okay, so it took a little to get set up. So that, let me just make sure we know this is for part A. It took a little while to get set up, but once we got it set up, it wasn't too bad to get going. So B was area equals probability, which was 10%. Or yeah, for the second one. Okay. Last but not least, find the weight of the baby elephant if the probability is between the two weights that represent the middle 50%. Oh my gosh, we have to go back to chapter 2 for this. Okay, let me draw a picture. Haha, that's going to be my answer to everything. Draw a picture. This is going to be a different picture. This is going to be a box plot picture because that is the time we were talking about this middle part. Okay, so here is a line. It's been a while since I've talked about this. Okay, cut it in half. Remember the 5-number summary? We had the end, and then we cut it in half, and then we cut the first half in half, and we cut the second half in half. And so what we determined was that each little chunk was 25%. Quartiles. Remember this? I can't be the only one that remembers talking about this. I'll double put the zeros and save some space. Each little part is 25. 25%. Each part was a quarter, a quartile, quartile 1, quartile 2, etc. Okay, this problem is asking for the middle 50%. Look at that. The middle 50%. Well, okay, just pretend that lines up. The middle 50% is right here. So as a reminder, our numbers underneath for quartile 1, quartile 2, and so forth were 0, first quarter, 25%. That's just like when you're going shopping, a quarter. Middle, 50%, 2 quarters, a half. Next up, 75%. And then we don't really do the end, but the end would be one whole, $1, 4 quarters. Okay, so if we're doing this middle 50%, we're going from 25% to 75%. Does that sound familiar? It should, because this is called, everybody, the IQR. Ding, ding, ding. Hopefully you remember that from chapter 2. Okay, so how does that fit on this picture? So I'm going to go back to my calculator. I have my mean is 234 and my standard deviation is 34. Remember, if you forget, you can just look right here at the top, 234, 34, perfect. Okay, go back. So then what I want to do is I'm going to go over, because I want the in-between parts. This is for part C. Write that already. I want the in-between parts, which is the second one. And I want to go from 25% to 75%. Oops. Oh gosh, I totally. Oh, look at that. 3, the answer can't be over 1. Okay. So let's just figure out where I messed up. I put the percents on the wrong side. I put the percents on the X side. So let's figure out what these X's are first, and then we can put them in our calculator. Okay, hold please. Okay, so I want to start with 75. No. 75%. Okay, just put whatever. Go back. 75%. And that X is 256. Oh, that's what I was even trying to find. Oh my goodness gracious, I didn't read the problem correctly. Okay, that's fine. I only typed one thing in the calculator wrong. All this picture right here is all fine. So we're trying to find the weights that represent these two, this range from Q1 to Q3. So I did 75% first. So Q3 to the nearest whole number is 250. And then the lower, go over here, my calculator, do it again, but this time with 25%, 211. Okay, because it said find the weight of the elephant. So I needed to find X and given the percentage. So don't type in 50%. We're not looking for this middle number here. We're looking for the middle half of the distribution, everything from 25 to 75. So 25 was 211 pounds, and 75% was 257 pounds. So it's everything between 211, 250. Okay. A couple more left. So let's get rid of some of this. What happens is if I do it in Zoom, I have to clear it. If I do it in the PDF, then it stays. So I'm going to clear all my Zoom stuff, and then the PDF stuff just rolls up with it, so it's fine. Okay, here we have scores on a biology test that are normally distributed. We have our mean, lovely, and our standard deviation. Are you underlining this before I even do at this point? Hopefully you are. And it says if P of A is is less than or equal to X is less than or equal to B is 0.25. If the probability is 25%, and A and B are symmetric about the mean, which means the mean is in the middle, we want to know the numbers on either side, find the values of A and B. Okay, what did I just say? So let's draw this. So we have our line, we have our, getting better. And we want, with the mean in the middle, we want it to be symmetric. So if I folded it in half, it'd be the same on both sides. I have this mystery number, this mystery number, but I know this middle part is the area or the probability is 0.25, because that's what it told us up here. So area, well, I shouldn't use A because they use a capital A here. I'll just say the probability. The probability is 0.25. Okay, so go back to my calculator, new problem. So I have to go back to the mean, it's too far, to the mean, 74, standard deviation is 5. Now I want an in-between picture, and I want the percentage to be 25%. And look at that, right in the middle, it's going to go, it says to the nearest integer. So we are going to go from 72 to 76. What are these scores? So 72 points to 76 to the nearest whole number. So 72, 76, perfect. Okay, if we wanted anything other than symmetric about the mean, it would have to be listed like above, where it's like what are the lower and upper percent. So if it just gives you the in-between percent, that's how you do it. Okay, we got lots of percentages down here, practicing kind of the last few things, which are the trickier ones, so that's good. We have for number 7, a mean of, we have milk. So we have a mean of 8.6 pounds and a standard deviation of 0.03 pounds. Find the highest weight. So it weighs less than, find the highest weight such that the weight less than this, oh, okay. This is what we want, the lower 80% of the distribution. So we have our picture. We draw our normal, and then draw a line where you think 80, where it cuts off lower 80%, upper 20%. Okay, ishy-ish, right about there. So we're looking at the lower 80%, which is all of this. P probability is 80%. Can't really see that, but that's okay. It doesn't matter. We know it's 80%. We're going to come over here. Mu is 8.6. Standard deviation is 0.3. And we want less than because it's lower. This is a percent, so it goes on the right side. And it tells us that the milk right here, so this picture looks like this picture, good to go. The milk must weigh at, the highest weight the milk can weigh is 8.85 pounds, because it says around to the 100th. So the highest weight of a gallon of milk is the 100th, 8.85. In order to be the lowest 80% of the distribution. Okay. Last but not least, it's a very similar. Notice it has the 8.6, it has the 0.3. This is last one, yeah. And so the difference is the middle 70%. So this time I don't have like a little IQR to talk about. I got to figure out what the middle 70% is. So let me clear some stuff out of here and let's look at how we can figure this out. Okay, so I'm just going to draw a number line. I'll draw the curve on top of it when we get there, but let's just talk about the number line for starters. The middle 70%. Well, I could draw it. It's okay. I'll draw it so we know what we're looking at. The middle 70%, that's more than the middle half. So it's like a little bit bigger. So maybe here to here. The middle 70% means from there to there is the probability of the in-between is 0.7. So we have our mu, we have our standard deviation, and because it's the same as the last problem. And I'm going to go here. I think I thought this was more complicated when I first started talking, so I didn't mean to scare you. We're just going to go to the in-between picture. And we want to go to the middle 70%. So we have the middle picture, we have the 70%, and it's always going to be that part I was talking about, the symmetric about the mean. I kind of drew over it right here, but it says it's symmetric about the mean. I'll just put a box around this. Because that's how it's going to be a pain in the butt if it's not. So it is. Oh wait, what are we trying? Yeah, we have our two weights right here. So it says, so let me type. Find the weight, assume that's the truth. Okay, so the lowest weight is for the nearest hundredth, 8.29 pounds, and the highest weight is 8.91 pounds. To be in the middle 70%. Thinking back, the whole IQR thing, while it was great to have a flashback, that blast from the past, I think I might have like over talked on that one. That's okay. I'd rather give you too much information than not enough. Any questions? Nope, I'm not hearing any, so I guess I'll go. Just kidding, I know you can't talk to me. Shoot me an email, any questions, so we can go over this, but I'm really hoping you are loving this calculator and you're seeing the benefits of it and that everyone is using it. There is a way to do this on graphing calculator. You can just Google it. It's a few extra steps, and I think it's a little more confusing what you have to type in, but if you love it, you love it. Scientific calculators cannot do this. So if you only have a scientific calculator, you're going to have to do this with the table. But this website's free, or you can get the app on your phone for free. So I really recommend this. All right, I will see you in